Okay, welcome back. This is section 1.2, graphs and lines. We will be graphing linear equations by using, I think, a couple methods, one by X and Y-intercepts and the other by Slope-Intercept Form. We also will be creating linear equations given certain pieces of information. And of course, we'll have applications at the end. Okay, so first page, little definition. The graphs of AX plus BY equal to C. This is a linear equation in two variables where A, B, and C are constants and X and Y are variables. All right. What does it mean to be a constant? A constant is just a number, right? Just a number. That's all what it means to be a constant. It could also be considered a coefficient. Okay. A solution of an equation in two variables is an ordered pair, x, y. The solution set of an equation is two variables, also x, y. And the graph of an equation is the graph of its solution set. Okay. Theorem 1, the graph of a linear equation in two variables, the graph of any equation of the form ax plus by equal to c is a line. And any line in a Cartesian coordinate system is the graph of an equation of this form. Okay, so linear equations are the graphs of lines. It makes sense. Linear line, right? Okay, one way to graph a line is to find its intercepts. We want to look for the x and y intercepts. So to find an x-intercept, we set y equal to 0. And solve for x. The reason we set y equal to 0 is because x-intercepts lie on the x-axis. If I showed this graph below, here's the x-axis. And to find an x-intercept, you set y equal to 0. Because if you are anywhere on the x-axis, y is always 0. Makes sense, right? Okay. And then to find a y-intercept, you set x equal to 0 and solve for y. And again, here's the y-axis. If I have any point on the y-axis, well, this means that x is always 0. And that's how you find a y-intercept. Okay. So now, given the linear equation, 3x minus 4y equal to 12, let's go ahead and graph it using intercepts. Okay, so the first thing we'll look for is the x-intercept. So we'll do that over here. The x-intercept. And to find an x-intercept, you let y equal 0. Okay, so we'll start with that. This will give me 3x minus 4 times, since y is now 0, you plug in 0 for y. 0 equal to 12. Here, 3x equals 12. Then solve for x, divide by 3. And x will equal 4. Okay. Now you want to put this into a coordinate form. We want to put it as a point. So x equal to 4 becomes the point 4, 0. That is our x-intercept. When x is 4, y is 0. There's the x-intercept. Okay. Now let's look for the y-intercept. Do that over here. Go for the y-intercept. And for a y-intercept, you let x equal 0. Okay. And we were using 3x minus 4y. Okay, so this would become 3 times 0 minus 4y equal to 12. So we plug 0 into the equation. This will leave me with negative 4y equal to 12. Divide by negative 4. And y equals negative 3. Once again, put it into a coordinate form, which means we would have 0, negative 3. There is our y-intercept. Okay. And x-intercepts and y-intercepts are probably the fastest way to graph a function. All you need are these 2 points. So let's go ahead and plot them. 4, 0. So let me see, what's good? I'll use this fun color here. There we go. All right, 4, 0. That means we look on the x-axis and we look for positive 4. So 1, 2, 3, 4. There's my first point at 4, 0. Then for my y-intercept, I go 0, negative 3. That means I go down 3 places from the center. 1, 2, 3. There it is. So there is my x-intercept plotted. There's my y-intercept plotted. All you have to do is connect the 2 points. Use the fun colors, right? And there it is. And I'll put the points there just to do it. There and there. There you go. That is one of the easiest ways to graph a linear function. That's it. Okay, so that's what an x-intercept and y-intercept is. Let's keep moving. All right. Next, we get into the definition of slope. You've probably heard of slope before. All right. So if a line passes through 2 distinct points, x1, y1, and x2, y2, then its slope is given by the formula m equals y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2, which is also known, which we always know it as, rise over run, right? Rise over run. Where, of course, the x values cannot be equal to each other, or we run into a problem. Okay, so the slope determines how your line will go, whether it's positive or negative. Okay, so in the next exercise, we're going to use the slope formula above, mainly just focusing on, which one am I using? This one? Yes. Okay, mainly just focusing on this formula right here. So we're going to use this slope formula. So down below, we are given 2 coordinates. And from what we know now is that between any 2 coordinates, you can find the given slope. So let's go ahead and try it out. Let's zoom in. There we go. Okay. And before I even begin, I like to label everything. It just keeps everything in order. So for this one, I'll have x1, y1, x2, y2. So all my points are labeled nice and neat. So this means that when I go to my slope formula, m equals y2 minus y1 over x2 minus x1. Since I labeled everything nice and neat, it just makes it easy to plug in now. So let's go ahead and plug in. My y2 is 4. My y1 is -2 over my x2, which is 3, minus my x1, which is -3. All right. Simplify it from there. And 4 minus minus 2. We know that minus minus makes plus. So that'll give me 4 plus 2 over the same thing down below, 3 plus 3. We get 6 over 6, which reduces to 1. So the slope between these 2 points happens to be 1, a positive slope of 1. Okay, do it again. Label everything. x1, y1, x2, y2. Let's go to our slope formula. M equals y2 minus y1 over x2 minus x1. And the reason I keep writing it is the more times I write it, the more times it burns into your brain. Okay, plug in. Y2 is -3 minus y1, which is 3, over x2, which is 2, minus x1, which is -1. Okay, now we have -3 minus 3 over 2 plus 1. Here we get -6 over 3, giving me a slope of -2. Okay. Still going, last one. Label it. x1, y1, x2, y2. M equals y2 minus y1 over x2 minus x1. And we get -3 minus -3 over 3 minus -2. All right, so what we end up with is -3 plus 3 over 3 plus 2. We get 0 over 5, which happens to be 0. All right, excellent. So that is how you find the slope between 2 points. So if you're ever given 2 points, you know you can find the slope between them. All right. Perfect. All right, geometric interpretation of slope. If the line goes from left to right, so from bottom left to top right, it is a positive slope. If the line goes from top left to bottom right, it is a negative slope. If your line is horizontal, you have a slope of 0. If your line is vertical, you have a undefined slope. Vertical lines have no slope. Okay. And I guess before we move on, a horizontal line will always be in the form of y equals some number a. A vertical line will always be in the form of x equals some number b. So if you ever see y equals a, just y equals a number, that's it. It's a horizontal line. If you ever see x equals a number, it's a vertical line. So we'll definitely be seeing those. Okay. All right. So special forms, we have the slope-intercept form, which we all might be used to. You see there, it's y equals mx plus b, where m is the slope and b is your y-intercept, right? B is your y-intercept. So 0, b would be your y-intercept. Okay. So we want to graph the linear equations below and label the slope and the y-intercept. All right. So for this one, we are going to graph it using the slope and the y-intercept. So here is our second method to graphing a linear equation. The first method we used was finding the x and y-intercept. This method, we will use just the slope and the y-intercept. Okay. All right. So for this problem, it's in the form of y equals mx plus b. Okay. Which means that if you relate it to the slope-intercept form, we're going to get that the slope is -3/2. And the y-intercept which is your b value, is 1, which we can put as 0, 1. Now let's go ahead and graph using just the slope and the y-intercept. It's good enough, right? Here's probably good. Okay, so the first thing we're going to want to plot is the y-intercept. So fun colors, let's do it. Okay, so the y-intercept is at 0, 1. That means I start from the center and I go up 1. So there's my y-intercept. Maybe too big. There we go. There's my y-intercept. And now my slope is -3/2. So my slope is negative. And if you remember from the picture above, it says that negative slope goes top left to bottom right. So that's how we're going to have to do it. So my slope is -3/2. So this means that I'm going to go up -3. Actually, I'll go down. I'll go down 3 and to the right 2. So I'll do that in another color. Let's do black. So I'm going to go down 3 for my y-intercept. 1, 2, 3. And I'm going to go over 2. 1, 2. here is my new point. And now let's do it again. 1, 2, 3 over 2. And why not repeat one more time? 1, 2, 3 over 2. All right, that's enough going that way. Now let's go the opposite way. So start back at the y-intercept, and now we're going to go up 3, left 2. 1, 2, 3. 1, 2. Again. 1, 2, 3. Left 2. And that should be all the points we need. And now let's go ahead and connect them. So let's see. Can I make a line? Let's see. Woohoo! Just like that. Yeah, close enough, right? Okay, perfect. And there it is. There's the graph of our line by using the slope and the y-intercept. Okay. Again. Example 2. 8x minus 3y equal to 24. So we must put this into slope-intercept form. So that means we're going to have to solve for y. So in order to solve for y, I'll take 8x and subtract it to the right side. So say minus 8x minus 8x, and we get negative 3y equal to negative 8x plus 24. And then to solve for y, we'll just divide by negative 3. So divide by negative 3, divide by negative 3, divide by negative 3. This should leave me with positive y equal to positive 8/3 x minus 8. There is our slope-intercept form of mx plus b. And now you can find the slope. Which is 8/3. So I'll say m is 8/3. And you can find your y-intercept, which is negative 8. So 0, negative 8. Okay. That's all we need. Come to the graph and let's plot. All right. So do it again. Plot my y-intercept at 0, negative 8. So that means from the center, I will go down 8. 1, 2, 3, 4, 5, 6, 7, 8. Right there. And now my slope is a positive 8/3. This means that my graph will go from the bottom left to top right. which means that from my slope, using my slope, from my y-intercept, we are going to go up 8 places to the right 3. So 1, 2, 3, 4, 5, 6, 7, 8, and then to the right 3. 1, 2, 3. All right, get rid of that one. Put the color I want. There we go. And do it again. 1, 2, 3, 4, 5, 6, 7, 8, and to the right 3. 1, 2, 3. There it is. We have no room for any more, so all we have to do is make our line. And again, close enough. Best I can get with this computer thing, right? All right, there you go. All right. So that's using slope and the y-intercept. Another way to graph. Okay. Next is example 3. Graph x equals -3 and y equals 2. Well, we saw an example of this earlier. I'm going to scroll up a bit. If x equals a number, it's a vertical line. If y equals just a number, it's a horizontal line. Check it out. It's what I wrote right there. Y equals some number a, it's a horizontal line. X equals some number b, it's a vertical line. And that's exactly what we have there. So let's start with x equals -3. All we have to look for is -3 on the x-axis. So 1, 2, 3. There's x equals -3. And x equals -3 is a vertical line. So I'll go ahead and draw that. I missed, but it's fine. How do I move you? Let's see. Move it. Move it. I don't want to do it over. Maybe I could get away with not doing it. Let's see. There you go. Good as it's going to get. So this is x equals -3. And then, what other fun colors? There we go. And then for y equals 2, that is a horizontal line. So find 2 on the y-axis, which is right there, and just draw a horizontal line going across. And this is y equals 2. Okay, and of course this wanted to know what was the intercept. Well, yeah, what was the y-intercept and what was the slope? So over here, for x equals -3, the slope is not defined, but it does have an x-intercept at -3, 0. At -3, 0, which is right there. And then for y equals 2, the slope is 0, because all horizontal lines have a slope of 0. Okay. And it has a y-intercept at 0, 2, which is right there, 0, 2. Okay, and there you go. That's how you draw a horizontal and a vertical line. Pretty straightforward. All right. Now, in the next example, we will be creating a linear equation given some important information. And we're going to use the point slope formula to help us create that equation. And the reason it's called a point slope formula is because it's telling you all you need to create the line. It needs a point and a slope. That's it. The only two things, the only two ingredients you need to make an equation of a line is a point and a slope. That's it. Okay, so example 4. Write the equation of the line through the indicated point with the indicated slope. Write the final answer in slope-intercept form. So here they're giving us that the slope is -6, and the point they're giving us is -4, 1. All right, like I do with everything, label it. Label what we're given. So let's look at this. One thing's already labeled. They're telling us that the slope is -6. And then all we need is the point. Well, this point is going to be my x1, y1. And we have a point and a slope. That is all the information we need to make an equation of this line. So I'll come over here, maybe I can make it a little smaller, there you go. And we will use the point slope formula. Y minus y1 equal to m times x minus x1. Just like the above. Again, I write it, and I write it so it burns into your brain. Now, all you have to do is plug in what you know. Y minus my y1 value, which I labeled above as 1, equal to our slope of -6 times x minus our x1 value of -4. Ooh, so many parentheses, right? So let's clean up a bit. This means you get y minus 1 equal to -6 times, and on the inside here, minus minus makes positive. So this leaves me with x plus 4. Okay, now distribute the -6. You get y minus 1 equals -6x minus 24. Add the 1 over. And we will have y equals -6 minus 23. And that's it. We have just made an equation of the line by using a point and a slope, by just using negative information. That is it. Not bad. Okay. 5. Let's do the same thing. Find the slope of the unique line that passes through the given points and write the equation of the line in slope-intercept form, and then write it in standard form. All right. And here we are given 2 points, 2, 3, and negative 3, 7. Well, if you remember from about 2 pages ago, what can you find between 2 points? You can find slope. So that's where we're going to have to start. We're going to find the slope between these 2 given points. Okay. So, like I do always, label everything. 2, 3 is going to be x1, y1. Negative 3, 7, x2, y2. And now the first thing on our list is going to be finding the slope. So number 1. Find the slope. You remember slope is given as y2 minus y1 over x2 minus x1. Plug in what we know. It's a good thing everything's nice and labeled. 7 minus 3 over negative 3 minus 2. You get 4 over negative 5. 4 over negative 5. Okay. And there is our slope. Which means we can move on to step 2, which is now find the equation of the line, which means we will use the point slope formula. Y minus y1 equal to m times x minus x1. Okay, plug in what you know. It's a good thing that we labeled our point x1, y1 already. We can plug that one in. You get y minus y1, which is 3, equal to m, which is a negative 4/5 times x minus x1, which is 2. All right, make this look a little pretty. You get y minus 3 equal to negative 4/5 times x minus 2. Okay. Distribute that 4/5. Y minus 3 equals negative 4/5 x plus 4/5 times 2 is 8/5. And since it's negative, negative, it'll be a positive 8/5. Okay. Running out a little bit of room. Sorry, wrote too big. It's okay. All right. And then almost there. You're going to add the 3 over, which will give me, here I can zoom in now. Y equals negative 4/5 x plus 8/5 gross. Plus 3. Oh, just awful, right? Okay. So we want to combine these two. So let's do that really fast. You'd make it 8/5. You would change 3 into a fraction. 3 over 1, multiply by a denominator of 5, you would get 8/5 plus 15/5, which would give me 23/5. So this means that we now have y equals negative 4/5 x plus 23/5. There's our slope-intercept form. Okay. Which brings us to the last step, putting it in standard form. So we'll call this 3. I'll fit this in here. Put it in standard form. And that is ax plus by equal to c. Okay, so this means that all we have to do, well, not all, first thing we're going to do is take negative 4/5 and add it to the left side. So what we should have is 4/5 x plus y equal to 23 over 5. So that's all I did. I took this 4/5 and added it to the right side, which became that. That's it. Okay, but now in order to put it in standard form, we don't want any fractions. So what we're going to do now is get rid of our fractions. And we've gotten rid of our fractions before by multiplying by a common denominator. This denominator is 5, that denominator is 5. This means our common denominator is 5. We're going to multiply both sides by 5. Okay. So that's what we're going to do. So I'm going to say 5 times 4/5 x plus y equal to 5 times 23 over 5. And now this 5 will multiply here and here. And 5 times 4/5 means that those 5s will cancel and leave us with 4x plus 5y equal to, and on the right side, 5 times 23 over 5, cancel, cancel. All we're left with is 23. And there's the standard form. Whew. All right, perfect. All right. So down below, just everything we've been working with: standard form, slope-intercept form, point-slope form, horizontal line, vertical line. There it is. All right. So now we can get into the applications. All right. So on these applications, what's left? Oh, just these last two. Cool. We're going to be finding the linear equations for these applications. We just have to notice that they're giving us the information. So let's try it out. So 6, a clothing store sells a shirt that cost them $20 and retails for $33. A jacket that cost them $60 and retails for $93. If the markup policy of the store is assumed to be linear, which means we're going to have a line, write an equation that expresses retail price in terms of cost. So our job is to make an equation. We just have to see what they're giving us. What information are they giving us? And they're actually giving us points. The shirt is $20 and retails for $33. So for A, the shirt costs $20 and we sell it for $33. There's the first point. And then the jacket cost $60, which is then retailed for $93. Look at that. And our goal is to find this equation. But before we find the equation, we need to find the two ingredients. And those two ingredients are point and a slope. Well, look at that. We found a point. We found 2 points. All we have left to do is find the slope. That is it. Find the slope. And lucky for us, what can you find between 2 points? Slope. So here's x1, y1, x2, y2. Let's go ahead and find the slope. M equals, I'm sure you've burned into your brain now, y2, which is 93, minus y1, which is 33, over x2, which is 60, minus x1, which is 20. This should give me 60 over 40, or 6 over 4, or even better, 3 halves. But now, I assume since we're in business math, and if you run a store or a business, you don't deal in fractions, you deal in decimals. So let's go ahead and change 3 halves into 1.5. There's the slope. Now, we have a slope, we have a point. Let's go ahead and find the equation. And to find the equation, we will use the point slope formula. All right, and you have y minus y1 equal to m times x minus x1. And it's a good thing everything's labeled, because now we'll have y minus 33 equal to my slope of 1.5 times x minus x1, which is 20. Okay, let's find this equation. And you'll have y minus 33 equal to, distribute the 1.5, 1.5x minus 1.5 times 20. Well, 1 times 20 is 20. 0.5 times 20 is 10. 20 plus 10, 30. Look at that. Now, add the 33. And we get our equation. Y equals 1.5x plus 3. This equation expresses retail in terms of cost. So retail in this problem is considered Y. Cost in this problem is considered X. which will lead us to our next question. B, what does a store pay for a suit that it retails for $240? Since retail is represented by Y, what number are you going to plug in for Y? And that answer is 240, because Y represents retail and X represents cost. So what this question is asking is, what are we going to pay for this suit that we're going to retail for $240? So on B, we are looking for the cost. We're looking for X. All right. So this means for B, we're finding the cost, which means that we're going to take 240 and set it equal to our new equation, 1.5x plus 3. Now, subtract 3, and you'll get 247 equal to 1.5x. Divide by 1.5, divide by 1.5, and, all right, calculator now, right? Oh, not 247, 237. Maybe I do need a calculator. There we go, 237. Divide 1.5, and we get $158 equal to X. So this is the cost of the suit. So we're going to buy the suit for $158, and we're going to sell it, we're going to retail it for $240. There you go. All right, that was fun, right? Sure. Now, on to the last one. The long one. Oh boy, buckle in. All right, depreciation. A charter fishing company buys a new boat for $224,000 and assumes that it will have a trade-in value of $115,200 after 16 years. Determine a linear model. Find the linear equation for the depreciated value, V, of the boat T years after it was purchased. Okay, so guess what we're going to find? The equation of a line is what we've done for the what? Last four examples? Let's do it again. I know. Okay, so A. And this one I'll write small. All right, so A. We are given points. And those points, let's see. V is the value, and the boat is T years. Okay, so this means that T is going to be kind of like X. So if we just bought the boat for $224,000, how many years have passed on the boat? And that answer is 0. So that's our first point. Our first point is going to be $0 and $224,000. There's the first point. 0 years, and the boat is brand new, so we bought it for $224,000. The second point is we want to know after 16 years, this boat will be worth 115,200. So there's our second point. So 16 years, $115,200. Okay, excellent. So we have 2 points. What can you find between 2 points? Slope. Let's do it. Seems like a broken record, right? X1, Y1, X2, Y2, and slope will be M equals Y2, 115,200 minus Y1, 224,000 over X2, 16 minus X1, 0. All right, 115,200 minus 224,000 negative 108,800 over 16. And this comes out to negative 6,800. There's the slope, which means now we can find the equation by using the point slope formula. All right, and I'm sure you have this one burned in your head now. Y minus Y1, which is 224,000, equal to our slope of negative 6,800 times X minus our X1 value of 0. Hey, that's cool. Okay, clean it up. Y minus 224,000 equal to negative 6,800X, because 6,800 times 0 is 0, right? Add the 224,000 over, and we'll get Y equals negative 6,800X. Well, we'll change it. This is supposed to be in terms of T, but I'll change it on the next line. Plus 224,000. Okay. So this problem says in A, determine the depreciated value V of the boat T years after it was purchased. So V is Y and T is X. So we'll just make a quick replacement down here. So we're going to say V equals negative 6,800 T plus 224,000. There you go. There is our linear equation that will represent the depreciation of this boat. Now let's go to B. B says, what is the depreciated value of the boat after 10 years? So all you have to do is plug in 10 for T. That's it. So I can write that right here. B. When t equals 10 years, what is the value of v? So this means you'll have v equals negative 68,000 times 10 plus 224,000. Go ahead and throw that in your calculator. Negative 6,800 times 10 plus 224,000. In 10 years, this boat will be worth $156,000. That is the boat's value after 10 years. All right. C. When will the depreciated value fall below 70,000? So now it's giving us the opposite of what B did. B gave us a t value, so we plugged in for t. C is giving us the value. It's giving us v. So we're going to take 70,000 and plug it in for v and solve for t. Yeah. Okay. So C. When v equals 70,000. You take 70,000 and set it equal to negative 68,000 t plus 224,000. Subtract 224,000 to the left. And I'll get negative 154,000. Oops, wrong color. You get it though. Negative 154,000 equal to negative 6,800 t. Then divide by negative 6,800. Divide by negative 6,800. And I think we'll round up. I get 22.65 equal to t. This means that in 23 years, the boat will fall below $70,000. Hey, that's not bad. Does anybody hold on to a boat for 23 years? I have no idea. I don't own a boat. Okay, there's C. Oh, and then we have another C. That's D. There we go. Graph our linear function v for 0 is less than or equal to t, and t is less than or equal to 30. So they're giving us x values to help us graph our function, right? So graph v between 0 and 30 years and illustrate the answer. Okay, So this part is just considered D. All right, maybe I'll make that higher. This is D. Okay, so they're giving us T. So the bottom is T. This one is V, right? Because V is Y, T is X. And they're giving us the number 0 through 30. So down here, I'll make these intervals appropriate. So here's 0. And what do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I have 11. Okay, so if I'm going to graph this, I'll just go by what? 5s? Or actually, better yet, what numbers did we find already? We have that, yeah, I can go by 5s. Because in 10 years, we'll be at 156. And then in 23 years, we'll be at 70,000. So yeah, I can go by 5s. And this is just a sketch. Doesn't have to be accurate. So I can say 5, 10, 15, 20, 25, and sure, 30 is going to be out here. So let me extend this a bit. There's 30. Make less of a mess. Okay, and then let's look at the Y values we have. We bought the boat for $224,000. In 10 years, it'll be worth $156,000. And in 23 years, it'll be worth $70,000. So let's go by, I say we can go by 50,000. Why not? And I think I can skip around on this one. So this will be 50K, 100K. I hope I can skip. 150K, 200K, 250K. Perfect. Okay. Now let's plot. So in 0 years, the boat was $224,000. So that's going to be somewhere around there. And then in 10 years, the boat is $156,000. So we'll just put it a little bit above there. How's that? And then in 23 years, the boat's going to be $70,000. So let's put that around there. Why not? And guys, that's all we need. Connect. That's it. Because over time, the boat's going to keep depreciating. There we go. Okay. And that's it. That's linear equations, guys. Graphing, solving, creating. That's all.